All right, 1.8 part 2. We're solving absolute value inequalities, all right? Same kind of thing that we did with our inequality stuff and the same kind of thing that we did with solving absolute value equations. We're just going to put it together. All right, remember, if you have less than or equal to, we're going to color in the middle, like the first two. If you have greater or greater than or equal to, you're going to color on the outsides. Remember, if it's closed in, has the line underneath. And if it's open, it's because it's not greater than or equal to, right? What I do want to bring to your attention, all right, because we're going to talk, when we talk about our inequalities, and I'll show you one of these, we're going to talk about a range of answers. It's not just one answer. So once we isolate our absolute value, right? So this is whatever number in here, blah, 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 right? If this is greater than or equal to a negative number, think about that. Is that always going to be true? No. What's the absolute value? Always. All right, absolute value is always positive, right? So if you have an inequality that says whatever this is greater than a negative number, is that always true? Yes. Your interval notation, your answers here would be negative infinity to positive infinity. Remember how when we had our absolute value inequalities, and if it was your absolute value was set equal to a negative number, we said, oh, no solution, that can never happen. Well, same thing kind of applies here, and I'll show you what I mean, but you can check your answers and you don't have to worry about like, oh, well, I remember that, because even if you don't, you can check. So we're going to do a couple examples. I'm not going to do every single one, but we're going to do a couple. But the main thing you need to remember, we need to take away from this, guys, do you see the absolute value right here? The first thing we do is we isolate our absolute value. Now, when we solved our equations, we made sure it was isolated, and then we set it equal to, this. In this case, it would be positive 2 and then negative 2, right? Well, with inequalities, we have to do something a tad bit different. We're going, since my absolute value is isolated, I'm going to say, okay, all right, I'm going to rewrite this. X minus 5 is less than 2. And then I have to make another statement on the other side. So I'm going to say X minus 5. If I change this to negative 2, would you guys agree with me? I'd be either multiplying or dividing by a negative number. Yes. So then what would I have to do to the inequality sign? Flip it. Every single time you guys have inequalities that have absolute value, you have to flip the inequality sign as well as changing the answer on the other side. So when we had our absolute value equations, we just changed the sign of the answer. But since we have an inequality, when you change the sign of the answer, you're actually multiplying or dividing by a negative number. So we're going to go through a couple of these, and then we'll talk about it. So once your absolute value is isolated, do you guys see how X minus 5 is in the absolute value? It's isolated. You can go through our little trick. It says X minus 5 is less than. Where do I color if it's less than? In between or on the outsides? In between. And then what kind of dots am I going to have? Open. Both of them are open because it's not or equal to. So now as we go through this, let's just add 5 to both sides. So I have X is less than 7. I'm going to add 5 here. And I have X is greater than 3. Agreed? All right, so when we graph this, I have to have 0 on my number line, 3 on my number line, 7 on my number line. Now, we told ourselves at the beginning what our graph should look like, but we can always go back and check it. So I have open dots at 3 and 7, and we said to color in between. Now, if you don't trust yourself, if you're like, oh, I don't know, graph this. If I say X is less than 7, do you guys agree with me that everything over here in green is less than 7, right? And then if I say X is greater than 3, do you agree with everything over here is greater than 3? So where they overlap is our solution, which is what we already have graphed. So you can graph both of your inequalities separately. And wherever it overlaps, it should be, but it's easiest, I think, if you just go from the beginning and do our little trick. Our interval notation would be what? How would I write? I can use everything from 3 to 7, but I can't use 3 or 7. Parenthesis 3, comma 7. Close your parenthesis. Perfect. Kiara, question? Yeah, question? Do what? Look, I have 2 number 2s. We're going to do the second number 2 and number 3. So again, the first thing you check, is your absolute value isolated? Is it all by itself? Yes. Is absolute value in this case greater than a negative number? No. Okay, so what we're going to do is we're going to say, all right, I have 2x is less than or equal to 20. And then I have 2x is greater than or equal to what? Negative 20. Flip the sign. Flip the inequality sign and the sign of your answer. Now, from the beginning here, since my absolute value is isolated, what kind of dots do I have? They're going to be closed. Why? Because it's or equal to. And it says less than. So where do I color if it's less than? In the middle. So let's just go through the solving. I'm going to divide both sides by 2. So x is less than 10. Divide both sides by 2. And x is greater than or equal to negative 10. Correct? Okay, let's graph it. Negative 10's on this side. 0's here. Positive 10 is here. You guys told me they were closed dots. And you told me to color where? In between. So let's just check. Plug in 0. What's 2 times 0? It's the absolute value of 0. 0. Is 0 less than or equal to 20? Yeah. All right, we're good. If you're not so sure, still pick something that's bigger than 10. If I pick something bigger than 10, should it work? Yes or no? Did I color over something bigger than 10? No. So plug in 11. What's 2 times 11? 22. Is 22 less than 20? No, so we're good. All right, look at number 3. Is your absolute value isolated? Yes. So I can say, okay, this one says greater than. That means I have open dots. And if it's greater, which way do we shade? Opposite. Good. Opposite directions. Girls, make sure you got this stuff down. So I have 2x is greater than 7. And then I have 2x is what? Less than negative 7. We flip the inequality sign and the sign of the answer. So just go through. I'm going to divide both sides by 2. So I have x is greater than 7 over 2. Divide both sides by 2. And I have x is less than negative 7 over 2. So I have negative 7 over 2 on this side. 0, 7 over 2. You guys told me they were both open. And you told me I colored on the outsides. So let's check to see if we did this correctly. What number is an easy number to plug in there? No, because it's greater. But what number is an easy number to plug in? 0. What's 2 times 0? What's the absolute value of 0? Is 0 greater than 7? No. Did I color that way? No. You can also look here. Look. This is telling me to go from 7 over 2 to the right. And this one is telling me to go from 7 over 2, which way? To the left. So interval notation-wise, I'd say negative infinity to negative 7 over 2, parenthesis, union, 7 over 2 to infinity. How come I use parentheses on everything? Because it's open. And we always use parentheses on infinity. We're going to do 8, 9, 10, and 11. We're going to do through the same process every single time. The first thing I'm going to do is circle my absolute value. If my absolute value is isolated, we're good to go. Is it isolated? Yes. Okay. So I can say, all right, this says less than. Which way do I color if it's less than? In between. And they're open dots because it doesn't say or equal to underneath. So I'm going to write my 2 inequality statements. 5x minus 2 is less than 6. What's the other one say? 5x minus 2 greater than negative 6. Good. So add 2 to both sides. I have 5x is less than 8. Divide by 5. So x is less than 8 over 5. And then over here, add 2. 5x is greater than negative 4. Divide by 5. And x is greater than negative 4/5. So on my number line, where does negative 4/5 go and where does 8/5 go? Oops. All right, negative 4/5 is over here because it's negative. Positive 8/5 is over here. It's positive, and I have 0 in the middle. What kind of dots did you guys tell me I have? They're both open. Now, we already saw which way we wanted to color, right? We said we're going to shade in the middle. But look, if I go this way from 8/5 and I go this way from -4/5, that is in the middle. And what number is really easy for us to check?
0.
0. Plug 0 in. What's 5 times 0?
0.
Minus 2.
2.
Good. So absolute value is 2. Is 2 less than 6? It sure is. So our interval notation would be bracket -4/5, comma 8/5 with brackets. Why is it a bracket? It shouldn't be, right? It should be what? Parentheses. Just want to make sure you guys are paying attention. We're a little quiet today. We're usually not. Right? We're going to use parentheses because it's what? Because it's an open circle. Okay, just make sure you guys are with me. All right, let's scoot on over to number 9. I need to isolate this absolute value. Isolate it. What should I do first? I'm going to add 3. Good. So I have 4 times the absolute value of x plus 2 is less than 16. Is x plus 2 isolated yet? No. Okay, so then divide both sides by 4. So you get the absolute value of x plus 2 is less than 4. Okay? We all right? Okay. Can this be true? Can the absolute value of something be less than 4? Yeah. Could it be less than -4? No, but it can be less than 4. So less than means I'm going to have open dots because it's not or greater than or equal to, and I'm going to color in the middle for less than. So I have x plus 2 is less than 4, and x plus 2 is greater than -4. Remember to flip the inequality sign and the sign of the answer. So we're going to subtract 2 from both sides. X is less than 2, right? Subtract 2 from both sides, and x is greater than -6. So I'm at -6, here's 2, and here's 0. You guys told me they were open dots, right? Now look, from 2, which way should I color? Right, but just looking at just this inequality is telling me from 2, which way should I color? To the what? To the left. From -6, it tells me to color where? To the right. So that just reaffirms that we're going to color in the middle. And then plug in 0 to the original. What is 0 plus 2? 2. The absolute value of 2 times 4 is 8, and 8 minus 3 is 5. Is 5 less than 13? Yes. So our interval notation would be parenthesis -6 to 2 and close your parenthesis. All right, we got a couple things going on here, so we need to make sure that we isolate, make sure all of our signs are correct. So I'm going to get absolute value of 2x minus 1 all by itself. So I'm going to first subtract 8, correct? You guys with me? And then I have negative absolute value of 2x minus 1 greater than or equal to -2. Is the absolute value isolated completely? No. Why not? Because there's a negative, guys. Watch. So I have to divide by a negative. When you divide by a negative, what do you do to your inequality sign? You have to flip it, right? So this becomes less than or equal to +2. All right? We treat this like we would any other inequality. We're not worrying about splitting them up into 2 yet. We have to make sure that your absolute value is isolated so you follow all the rules if you multiply or divide by a negative number or such. So now that we're here, are we isolated? Yes. So what kind of dots am I going to have? Close. Good. Close dots. And where do I color if it's less than or equal to?
Out, right?
Less than is in the middle. Gray tours on the outsides, this one or that one. So I have 2x minus 1 is less than or equal to 2. What's my other inequality sign? Good. 2x minus 1 is greater than or equal to -2. So go through our process of solving. We have 2x less than or equal to 3. Divide both sides by 2. I get x is less than or equal to 3 over 2. Add 1 to both sides here. 2x greater than or equal to negative 1. Divide by 2. And I get x is what? Greater than or equal to negative 1/2. So what kind of dots did you tell me I had? Closed dots. I have 3 over 2, negative 1/2. Now look, if I'm looking at these each independently, it's telling me from my closed circle at 3 over 2, which way should I color? To the left. And it's saying from my closed circle at negative 1/2, which way should I color? So that just confirms that we're supposed to color here in the middle. What should you plug in just to make sure? 0. If I plug in 0 into the original, what's 2 times 0? Minus 1. Negative 1. What's the absolute value of negative 1? So 8 minus 1 is 7. Is 7 greater than or equal to 6? Yes, we're good. If you're still not 100% sure, pick something outside of the range. Let's try 2. Positive 2. What's 2 times 2?
4.
And 4 minus 1 is?
3.
Absolute value of 3 is 3. So 8 minus 3. Is that greater than or equal to 6? No. So we're right. We're good. And then how would I write my interval notation here?
3, 2. I meant 3 over 2.
No, left to right, left to right, left to right. Negative 1/2. No, you're not. Just follow your graph. Negative 1/2 to what? To 3 over 2. And a bracket. Good. Okay, every now and again, guys, you get one of these tricky ones. You might see one of these, like I said, on your quiz, which is Friday. You might see one of these on the review. Now, the first thing we do, we're going to treat this like normal. We're going to isolate our absolute value, right? So the first thing I do is subtract 5. So I have 7 times the absolute value of x plus 2 greater than negative 1. And then I divide both sides by 7. So I have the absolute value of x plus 2 is greater than negative 1 over 7. What did I tell you at the very beginning? Guys, you should be able to look at this and see this. The absolute value of anything is always what kind of a number? Positive. So in this case, this statement of absolute value of x plus 2 is greater than negative 1 over 7, that will work all the time. There's never a situation where it doesn't work. So you could stop right here and see that this is saying that the absolute value is going to be greater than a negative number, which is true. And you can just tell me that my answer is negative infinity to positive infinity. It's all real numbers. You could do that. Now, if you don't see that right here, that's totally fine because you'll notice something here in a second. If I just go through the motions, all right, what is this inequality sign telling us to do? If you don't see this right now, we'll pretend like we didn't see it. My inequality is telling me to color where? Outside, because it's or. So it's open circles and to go on the outside, right? Okay, so I have x plus 2 is greater than negative 1 over 7. And then I change this one to x plus 2 is what? Less than good, positive 1 over 7. Okay, so let's just go through the motions. We have a fraction here. Girls, don't freak out. I was waiting for it. So look, I'm going to subtract 2 from both sides. When I subtract 2, would you guys agree with me that the whole number 2 is the same as 14 over 7? What's 14 divided by 7? 2. So I'm going to change this to 14 over 7. So negative 1 and negative 14 gives me negative 15 over 7. Agreed?
Can you just write 2 and negative 1, 7?
Yeah, that's fine. So here I'm going to subtract 2 again. So I'm going to subtract 14 over 7. And I get x is less than negative 13 over 7. So now when we go to graph this, all right, we're going to graph based upon what we have here. So I have negative 15 over 7. I have negative 13 over 7, and I have 0. Now, where are they, according to for where we started, our little trick, they're telling me I should color which way? On the outside. So I have my open dots, and I go to the outside. All right? Now, what do you notice? I actually said this at the beginning. So what do you guys notice about the inequality sign itself? This says they want everything that's greater than 15 over 7. And this says everything less than negative 13 over 7. Well, where is that on this graph? It's in the middle. It's in here. You guys see that?
Wait, say again.
Okay, look. From the beginning, right here, when we had our absolute value isolated, according to our little trick, it's gray tor. That means we shade outside. And it's not including negative 1/7 because it doesn't have equal to underneath it, right? Mm-hmm. But when we look at our actual inequality statements here, this says x is greater than negative 15 over 7. That means I would color from negative 15 over 7 this way. And then this one says I would color from negative 13 over 7 this way. So what do you notice? Where did you color on your number line?
I colored out.
And also, where else can we color? In. Why can we color on the outside and the inside?
Because they're pointing.
But think about what this says right here. Absolute value is greater than a negative number. That's always going to be true. So that's one of those. If you ever have absolute value is greater than or equal to a negative number, your answer is all real numbers from negative infinity to positive infinity. So if you guys are sitting here saying to me, oh my gosh, how am I supposed to remember that? The easiest way to do that is to just check every single problem you do. You get here and you shade it in the middle, right? You shade it in the middle and you're not sure. Wait, what if it is all real numbers? Well, check. Check a number bigger than 3/2. Try 2. If I plug in 2 to this original, which is what we just did, 2 times 2 is 4 minus 1 is 3. 8 minus 3 is 5. Is 5 greater than or equal to 6? No. So you shaded correctly. If you have any questions, look here. Okay, shoot. I don't know. I don't know if it's going to be all of it or not or whatever. So then pick 3. Right? If I put 3 in here, 3 plus 2 is 5. 5 times 4 is 20. And 20 minus 3 is 17. Is 17 less than 13? No. So then I shaded correctly. So if you guys get stuck and you're like, oh, I don't know if this is going to be one of those crazy all real numbers, just check a bunch of spots. But if at this point you realize, oh, look at this, absolute value is always going to be greater than a negative number, it's all real numbers, you can stop there. But if not, you can there's little places like right here when we said, oh, the way that the inequality is set up, I have to graph outside. But then when I got my answers, it shows me to graph inside. That's another hint. But again, if you don't see it, just check different spots. Now, the likelihood of this happening is not great. All right? You might every now and again you get one of these, but there probably will not be one on every single quiz version or something like that. So don't just automatically assume, oh, it's all real numbers. Don't do that. It could happen though.